Yeah.
Now try to solve this problem. You have to find the acceleration of the blocks. What is the acceleration of the block? Will it be same or different? Suppose I call this acceleration as A1. Let me assume it's going down. This is going with acceleration, say A2, and let this thing go up by acceleration A1, because I'm not sure whether they are same. So let me call that A1 and A2. Okay. So
Yeah.
So can you relate A1 and A2? The same.
Yes.
Did you take notes while watching the video? Acceleration of 2 kg is say A2, and let it be moving down. And when it's moving down, this 1 kg will move up, right?
Yeah.
Okay. And let the acceleration A1, because I'm not sure whether they are same or different. Okay. So the first question is, are they same? And how can you relate them?
Okay.
Are they same, first of all?
Yes, sir.
So did you take notes while watching the video? You have not. That's the problem. That's what, when the video you're watching, you will understand everything. When I'm teaching, you'll understand everything. After you forget. That's why you have to take notes and revise it. Okay. So the thing is, suppose if this thing is coming down by a distance x, okay. So this string is moving up by a distance x, right?
Yeah.
And this thing is coming down by a distance x. Okay. So this whole thing will move up by a distance. So the string length is moving by x, right? So on this side will be x by 2. On this side will be x by 2. Because the string length will get shortened by x, no? So the two sides will get split up by x by 2 and x by 2. Okay. So the pulley will move up by x by 2. This 1 kg will move up by x by 2. Is it clear?
Yeah.
Let the 2 kg go down by x. Because the string is moving by x. Okay. So when the string is moving by x, okay. My way of doing it is, see, I'll fix a reference point here, origin, and I'll measure x from this. This is my x-axis. Okay. So the coordinate of this point is x2. Okay. And the coordinate of this pulley is x1. Right? And x1 and x2, are they changing with time? You're getting my point, right?
Yeah.
Okay. I'm fixing my coordinates like this. This is the origin of x-axis and this is the direction of my x-axis. Okay. So using that, the coordinate of 2 kg is x2. I'll call it x2. Okay. And the coordinates of this pulley, which is same as this 1 kg block, is x1. Okay. So using that, what is the distance from here to here? What is this distance? X2, right? Because the coordinate of 2 kg block is x2. So this length is x2. And my positive direction is, I've noted here. Audio is clear, no? So this blue length is x2.
Yeah.
Okay. Similarly, this length This length is how much? This green length?
X2.
No, the coordinate of this point is what? X1, right?
Yeah.
1 kg. So this length is X1. This green length is X1.
Okay.
Okay. So the length of the string is is 2x1 plus x2. Is that right?
Yes, sir.
Length of string is 2x1 plus x2 because this is x1 and this also x1. This length. If I forget this length, okay, that doesn't matter. I'll explain you later why it doesn't matter. Okay, so this is x1, so this is also x1, and this length is x2. Okay, x2 is different from x1. In this figure,
Okay.
it might look as if they are same, but once this 2 kg blocks moves here, okay, this pulley will move here, then x2 will become this one, and x1 will become this one, right? So x1 and x2 are not same, but these two sides will be same. This side and this side, because of the same. So two sides of the same pulley. Okay, so left side will be x2, and this also will be x2. Correct?
Yes, sir.
Okay, so the length of the string is 2x1 plus x2.
Okay.
This is 1x1. Okay, this is the second x1. Right? I'm forgetting this length. It does not matter. I'll tell you later why. Okay, so this is x1, this is x1, and this length is x2.
Yeah.
The length of the string is 2x1 plus x2, and length of the string is constant. It's inextensible string, right?
Yeah.
Okay, now I differentiate this thing with respect to time on both the sides. So that is represented as dot. It's actually dl by dt. In short, I can represent as dot. Okay, so this is 2x1 dot. Dot is d by dt, 2x2 dot. And length of the string is not changing, so this is 0. Okay, and this is 2v1 plus v2, where v1 is the velocity of the 1 kg and v2 is velocity of 2 kg. Now I differentiate this thing again. Second time, I'll get 2a1 plus a2. Is that clear? If I differentiate velocity, I'll get acceleration.
Yes, sir.
So from that, I'll get a2 equal to minus 2a1. Okay, so right, so a1 is half of this thing. So okay, so this thing is moving down by acceleration a2 is 2a1, right? So this is moving down by, so this thing will move up by acceleration a by 2, or this thing is moving down by acceleration 2a. This 1 kg will move up by acceleration a. Is that clear? A2 is more. A2 is twice of a1, and the direction is opposite. That's why they get the negative sign. 1D problem, you can capture the direction by the sign of the quantity. And I have defined my positive sign as downward. Okay, so this thing is positive. 2 kg block is moving down by 2a, and this 1 kg thing is moving up by a. Right?
Yes, sir.
Okay, now we can write the equation, free body diagram of 1 kg and 2 kg and get the answer. The important step in this problem is to relate the acceleration to two blocks.
Okay.
Now we know how to proceed. Right? This 2 kg will have 2g and then tension T, and this acceleration is 2a. And this 1 kg block, what is the upward force here? What is the upward force on 1 kg? Once we get the acceleration of the blocks, you can draw the free body diagram. Right?
Yeah.
That is simple. So this is a free body diagram of 2 kg block, and this free body diagram 1 kg. What is the upward force here of 1 kg?
A.
No, upward force. Here there is a string, no? 1 kg block, something is pulling up. That is 2T.
Okay.
Because if you draw the free body diagram of the pulley, bottom there is a tension, say T1 or T2, whatever, and upward there is two tensions, T and T. The string is same and it is massless and inextensive. The tension is throughout the string is constant. Okay, so this tension which is pulling up will be 2T. That will get with the free body diagram of the pulley. Is that clear? This one, right? Your mic is off.
Yes, sir.
So, okay, from this we can write the equation and solve for T and A. It's a trivial thing. You already done it. Okay, the important thing is this thing. So this method you understood, right? The length of the string is constant.
Yeah.
So from that you will get the relation with the accelerations. I always prefer this method, but otherwise you have to reason out by some other method which I'll get confused. Okay, so this method is clear, no? Okay.
Yeah.
Similarly, find the tension and acceleration of this block. Just try to break the acceleration of these two blocks. The rest of things is trivial. Just find the acceleration of these two masses. Let this acceleration be, let me call it A2, and let this thing say move down by acceleration A1. So you have to relate A1 and A2. Can you get the answer?
Okay, sir.
Have you got the relation? Hello? Not good if you have to fix the problem, no? Okay, is this clear? I have drawn
Yes,
the
sir.
x and y axis like this.
I got A1 by A2 is equal to minus 1 by 2. Okay, it's same, yeah.
Okay, you did by different method, no?
Yeah.
Okay. I usually do by this way. I just fix the coordinates like this. So the position of this 3 kg is x2. Okay. And the position of this 1 kg block is y1. They are in different directions. Okay. So, and the length of the string is x2 plus 2y1 plus this length l1. Is that clear?
Yes, sir.
So from this, if I differentiate, I'll get this one. I have to differentiate twice. So a2 is minus 2a1. Okay. So in the free body diagram of this 1 kg, suppose the tension in the string is T.
Yeah.
So what is this force here that's pulling up? String will always pull. So this there is a string here which is pulling this 1 kg block. What is the force here? It is 2T.
2T.
Your mic is going off.
2T. 2T.
That will get from the free body diagram of the pulley. If you draw the free body diagram of the pulley, it will be T here, and there will be a downward force, say T1. So from this you get T1 as 2T. Right? So once you get this free body diagram, then it's a trivial thing. Okay. So you don't have to solve
Okay.
further. Okay, what about this one? Here this block this is the floor. Okay, the block will not leave the floor. And I'm pulling the string this way. So the block will move in this direction.
So we have to calculate the component.
Yeah, so let the velocity of the string be, say, Vs, and the velocity of block be Vb. So what is the relation between Vs and Vb? So what relation are you getting? Velocity of string is more or block is more?
Velocity of string.
No.
Huh?
See, I've done by my method. For x, I'm measuring from this. This is the origin of x, and x I'm measuring in this direction, and y I'm measuring in this direction. Okay, so the length of this length is x. Okay, and this length is y, and let this be at a height h.
Okay.
So from this I'll get x square plus y, h square equal to y square. It's a right angle triangle, right?
Yeah.
Okay, so now I differentiate both the sides. H is a constant, so it will become 2x x dot plus 2y y dot. X dot is velocity of the block, and y dot is velocity of the string. Okay, so it's x by y into velocity of the block is velocity of the string. X by y is cos theta.
Okay.
Okay, so that's why I always prefer this sort of method.
Okay, sir. I'll solve by this method only.
Here we will not get confused.
Yeah.
And another important thing is here theta is a function of time. It's not a constant. When I pull the string, the block will come closer and the angle theta will increase. Is it clear?
Yes, sir.
Theta is a function of time. Okay. Right. Try to solve this problem.
Sir, T1 is equal to 50 Newton and T2 is equal to 20 Newton.
Okay. So did you draw the free body diagrams?
Yeah, free body diagram.
Suppose I want to find the tension at this point, just below this 2.9 kg, how will you do that? You got the point, no? The lower string, it has got a mass. It's not massless. Okay. So the
Yeah.
tension in the middle point you have found out. Okay. Can you find the tension just below this 2.9 kg? Tension at this point where I mark by blue. This point just below this 2.9 kg here. So you can take this half string here from here to here. That string, that is this one.
Yeah.
Right? And then you can draw the forces. The above force is T3. Tension string will always pull. So this is pulling this thing with the tension of T3. Bottom it's pulling T1, T2. Okay. And that you have found out as 20 Newton, right?
Yeah.
Okay. And the whole thing is moving up with an acceleration E. Okay. And the mass of this thing is how much? It's 0.2 kg per meter, and the whole thing is 1 meter. The whole mass is 0.2 kg. So the half of the mass is 0.1 kg.
Okay.
Okay. So it's moving up. So T3 minus T2 is 0.1 kg. So T3 is 1 plus 20, 21 newtons.
Okay.
Okay. So as you go up, the tension is more. Suppose the tension is suppose the string is massless, then this m into a is 0, right?
Yeah.
A is not 0, but m is 0. So m into a is 0. So that's why T3 equal to T2.
Okay.
So that's why they give the condition the string is massless in most of the problem. Once the string is massless, if you draw the free body diagram of the string, m into a is 0. So that's why the tension at any two parts of the string should be same.
Okay.
Okay. Otherwise, the string has to be at rest. Even if it has rest, and if it has got mass, then also tension will be same throughout. Because in that case, acceleration is 0.
Okay.
Okay. This problem.
Sir, what is a diameter?
You can forget that term. It's not important. Basically, it has got two masses here, 6 kg and 4 kg, and there is a spring. You can forget that word dynamometer. Okay.
Okay.
So dynamometer reading means basically the spring will stretch or compress, right?
Yeah.
So basically, you have to find how much it is stretching or how much it is compressing. And since the spring constant is not given, you just have to find the tension in the spring. The string is stretched by x centimeter, x length, then the tension in the spring is k into x. So you just have to find the tension. That will correspond to the reading. Free body diagram.
Yes, sir. I drawn and just solving the question.
Yeah, you just have to find T.
So T is equal to 16 Newton.
14.
No. 14 Newton. Sorry.
So these are the two equations you got, right? 6a equal to 20 minus
Yeah.
40. You have to divide.
Calculation error.
Yeah. And you know this operation, right? Numerator plus denominator divided by denominator. You can do on both the sides of this one, the previous step. And that you get.
Yeah, it's like adding one on both sides.
Right. Okay, this one.
No, this I did not do.
Okay, just try this one. This is a bit complicated.
40 to 40, 43.
What is the
You
minimum
did.
value?
Sorry.
You have to find the range of tension, right?
Yes, sir.
So what
Range
is
of
the
tension.
minimum value of tension is how much?
Hello.
Minimum value of tension. You got the minimum value of tension.
Sir, 40.
Maximum value.
44. 43-ish.
Yeah, 43. Because G is 10. Okay. So how did you get those values? Can you just
Sir,
okay. Let me assume that the thing is trying to move down. This thing is trying to move down, and this thing is trying to move up. Okay. So then the friction force, this thing will be up here, and here will be down. Is that clear?
yes, sir.
I'll make an assumption and then check whether it's correct or not. Okay. And then the forces here are tension, and this is the friction force. So this is my equation. 6G equal to, okay, here the friction force is mu to n, right? Normal reaction is this one. Then mg cos theta. Is this clear? Normal reaction in one.
Yes.
And similar normal reaction in two you can find. So once I get this normal reaction, and mu is okay. And this thing is mg sine theta, right? The downward force. Okay.
Yes, sir.
So the downward force is 6G. And that is equal to the upward force T plus F1. Okay. Similarly, the downward force here is 4G, which is equal to the that is moving up, right? So T minus F2 is 4 into G. Okay. The downward force is 4G, and the tension is upwards, and the friction force is also downwards. So if I equate these two forces, I'll get 4G equal to T minus F2. So these are the two equations. Okay. So I have drawn this table. Okay. F2 is variable force, friction force is variable. It will go from 0 to the maximum force. Similarly, F1 is also variable. So I'll just check whether F2 0 is possible. If you put F2 equal to 0, then I'll get F1 as 2G and tension as 4G. Okay. Then I'll put F3 as 0.3G. That is coming from the limiting value. Okay. So if you put that, I'll get F1 and T as this one. Okay. So to get the tension to be minimum, F2 should be 0.
Okay.
This right hand side is constant, 4G is constant. Okay. So from this one, for the tension to be minimum, F2 has to be 0. So I'm just checking that one. And here, for the similarly for the tension to be maximum, F1 should be maximum. Because the left hand side is constant. Okay, so what is the maximum value F1 I can reach? I'll just check whether F2 is reaching maximum and find the corresponding F1, and F1 maximum is 2.4 G. Before that, the F2 is reaching its maximum value, and I'm assuming this case where the thing is not moving. Okay, so F1 cannot go beyond this 1.7. Okay, so here I assume the case it's stationary and the tendency is to move this way. We can, second case will be, you assume that it's trying to move this direction. You will see that there is no solution there. There will be some contradiction. The third case will be the blocks are moving. Okay, in that case, you have to use kinetic friction. Then in that case, the friction F1 is not variable. It is a constant. F1 and F2 are constants and will be equal to mu K into normal reaction. You'll find when it's trying to moving, a solution is not possible.
Okay.
Okay, so that will be the complete solution of this problem. Okay, this one you have tried.
Yes, sir.
Okay, you understood this question? See,
Yes, sir. It's a bit difficult, but I understood.
Yeah. See, when this string is cut here, okay, so this thing will move like this in a circular motion. Okay,
Yeah.
and just after it is cut, it will have a movement in this direction, tangential to the to this string. But here, when this is cut, this will move in this direction. In addition to that, it will move like this because the spring will get stretched further. Because the previously the 2 kg mass is balanced by two springs. Once one spring is cut, the full 2 kg is balanced by one spring. So the string will try to stretch further. So this extra movement will be there compared to the string. This string is inextensible, but spring can stretch. So there will be two movements here, one along this direction, one along this direction. So there will be two accelerations, whatever you want, A1, A2. So you have to find the next net acceleration. Here there will be only one acceleration in one direction. Okay. So fine. I think you have tried all the problems then. Okay. So what I will do is I'll put my coordinate system here, and this is my direction of x. Okay. So this string length, coordinate of this mass is x1. Okay. Coordinate of this mass is x2. This is a fixed length, and x2 is this length, right? And this is x1. This is x1. Right. Now I have to express length of the string in terms of x1 and x2. Okay, so right. So length of this string is how much? This length is how much?
X1 minus XC.
X1 minus xc. Okay, and length of this string is how much? It will be x2 because this is a constant length.
Yeah.
Okay, I can assume this is small, and so this length is x2. So this length is x1 minus xc. And what about this length? It's x2 minus xc, right?
Yeah. X2 minus XC.
Right. So the length of the string is x1 minus xc plus x2 minus xc plus x2. Is that right? Right. There is one more length. See, the string is this one, right? This is a string. It goes like this, goes like this, like this, like this, and then like this. Right. That is the full string. So this string is x1 minus xc, and this is x2 minus xc. This is x2, and this above length is xc. Right.
Yes, sir.
One xc is cancelling, one xc is remaining.
No, sir, this one was doubt. I had to ask you. Yeah, this one I did not get. Can you explain?
All surfaces are smooth. Displacement block E. 1 second. Okay. So the B is going to move down. Okay. So whether there will be slipping of A or not, A on B. That is the only question. Block is okay. All surfaces are smooth, right? So when the block B is moving down, it's a non-inertial frame, right? If
Yeah.
I fix my frame to B, so there will be a pseudo force acting on block A.
Okay.
So that is the only addition. Is moving down, right, with an acceleration A. That you have to find out. After that, if you draw for drawing the free body diagram of block A, you have to put a pseudo force in this direction. Okay, so this problem is solving the frame attached to this block B. So this is the frame in which I am solving this problem. Okay, so this frame, the friction force, and this is moving down. So there is no friction, no, it's smooth. Okay. So you have to find the velocity of block A. Okay, it will be accelerating. So the block A, these are the forces. The normal reaction, the mass mg. I'm assuming the block of mass m. Okay, this mass. Okay, both the masses are m. Okay, so and then you have to find this normal reaction from this other one, from the free body block B. This is block B. This is a normal reaction downwards, and there's one more normal reaction here. We call it M2, and this is moving down with an acceleration A. Okay, so you have to find acceleration, and then okay, I'll tell you next time this one. But this is the basic idea.